Well, team, I think we did a pretty good job navigating in this road rally. But right now, we want to see just how good you can navigate on your own. We're going to send them on over to Northampton Middle School, which is located on the eastern shore of Virginia, where you're going to meet up with science teacher Barbara Haynes and her students who are involved in a navigational challenge. For me, I'm going to head on back to the NASA Connect studio. I'm going to walk back there, send you to the eastern shore, and Van, how about you park in the car?
Oh, well, sure. I think I might even check out a new location on my GPS.
Sounds good. All right. See
Alrighty.
ya.
Bye.
Hi, we're students from Northampton Middle School, located in Matchapungo, on the eastern shore of Virginia. NASA Connect asked us to investigate angles and directions by plotting a course on graph paper using a compass, rose, and ruler. Our goal is to establish 5 outdoor pathways mapping direction and distance with 5 separate teams using a compass, rose, and transit. We hope our 5 different paths will converge at a single point. Here are the materials for an experiment: 5 rolls of different color tape, 5 markers, tape, 5 compasses, 5 large compass rose transparencies, 15 pencils to be used as field point markers, 15 pieces of paper marked with the letters A through J, and 5 X's, meter sticks, 5 paper towel rolls, thread, 5 scissors, and before we go outside, we plot our course on graph paper.
We need to review some simple vocabulary terms to help us prepare for this activity. The bearing is position or direction of an object or point based on a compass reading. Navigation is the science of finding distance, direction, compass positions, and time of travel to establish a course or determine a certain position on a map. Triangulation is the mathematical and scientific determination of an unknown position using distance or bearings from known positions. A transit is a sighting device used in surveying to plot a course or establish levels or heights. Having reviewed these terms, we are now ready to divide into 5 teams: Team A, Team C, Team E, Team G, Team I. We divide tasks among team members before navigating our course. One person will call out the bearings and distance and takes care of field position marks. One person handles the compass and compass roads. The third person handles the transit sightings. A fourth person handles the tape rule and measurement distance. And a fifth person checks the transit sightings and distance measurements.
The first step in our activity is to create the transit. We take the paper tube and cut 4 slits into the end. Each slit should divide the diameter of the tube into quarters. Now put the string into the slits. This will create crosshairs, giving us greater accuracy as we look through the tube. Next, the tube is attached to a meter stick. We then mark 3 separate pieces of paper with 3 position letters for our group. Group A marks A, B, X. Group C marks C, D, X. Group E marks E, F, X. Group G marks G, H, X. And Group I marks I, J, X. These pieces of paper will mark the points on our course. Now we're ready to go.
Here are the procedures. Each group lines up exactly 4 meters apart with the letter designating our team on a line facing magnetic north. We mark our starting point and hold the compass over the starting point to confirm magnetic north. We also set the transit up at the starting point. Using the compass rose as our guide, we turn the transit to the first bearing on our chart. For your experiment, remember, north 0 degrees must always be pointing to magnetic north on the rose, the appropriate direction. We then use the transit as a sighting guide and direct the student with the tape rule to the appropriate direction. It's okay to use hand signals to direct the person left or right. Once we find our correct bearing, we measure out our distance and mark the point with a pencil and paper with the appropriate letter. We then pick up the transit and move to point number 2 that we just determined. We complete leg 2 according to the chart using the same procedure. When all the groups finish, we check for navigation errors. Did everyone arrive at the same point X? Now that we have finished our field experiment, we are ready to apply this knowledge to questions involving flight paths, distance, and time.
All right, joining me in the studio are some friendly faces involved with GPS. But before we talk to our researchers, let's give you a chance at some navigating that will involve calculating flight paths, distance, and time. Then after this segment, our 2 researchers, Dick Hushen from NASA and Hugh Bergeron from the FAA, will answer your email questions and take questions from some students attending a special anniversary event in Washington, D.C. as guests of the FAA. Okay, now, look carefully at the data and using the information in the following diagram, work with your fellow students to answer the questions as read aloud by Mr. Rodney Slater, Secretary, U.S. Department of Transportation.
What is the total distance in miles of an airplane flight that starts at point C, goes through point D, and ends at point X? What is the total distance in kilometers? Now here's a hint. Use the formula to convert miles into kilometers. How long would it take an airplane traveling at 300 miles per hour to fly from point C to point D? From point D to point X? How long would the entire flight take? How many miles are there in a direct flight from point C to point X? Here's a hint. Use the Pythagorean theorem to find your answer.